Hi everybody, it's Mrs. Ellsworth. What we're going to be talking about today is a little bit about an introduction to organic chemistry, talking about carbon and its compounds. So, moving forward, carbon can be in all kinds of different shapes. And because of its unique ability to have several bonds, it'll have 4 bonds on it and is able to make several really cool allotropes when you think about it. So diamond is a very strong one. Because of its tetrahedral shape. Graphite is flat and it has got several different layers to it. So when you think about your pencil, it is layers are coming off of the graphite pencil lead that we call it, and it's pretty cool how that is. Notice that the fullerenes, that they can be either in tubes or else fullerene shapes with the buckyball right here, or else soot. And that's just a jumbled mess. There's no particular shape to it, but there's something else that's kind of on the cusp of new science, and that's graphene. And we don't have great time to go into detail about that, but it's just one layer of graphite, and it has got some extreme capabilities of electrical energy and all kinds of different ideas for being really strong. And anyways, you can check out stuff. It's changing all the time, but they haven't gotten into mass producing it. And then now here I was talking about carbon having unique capability. Remember electron configuration? So in the second energy level, we've got 2 electrons out there, so our Lewis dot structure is like this, and each one of these will make a bond. We have strong covalent bonds on these, and when it's between a hydrogen and carbon, then it's got some really strong capabilities. In fact, when you do a carbon-to-carbon bond, you can get single bonds, double bonds, and triple bonds, and we will talk about that more in detail too. But you can also get really long polymers, long chains. Moving on to the next. I just want to remind you that hydrocarbons is what we're talking about the whole time. So that is hydrogen and carbon. Makes sense, hydrocarbons. So let's look at some of these things here. I've got a single bonded molecule right here. It's all single bonds. Here's one that's got all double bonds right here. It's got one double bond between the 2 carbons. H's will never have a double bond to them because they only have 1 electron in their outermost shell, so they'll only be able to make single bonds. Here are some triple bonds. Right here's one, and right here. They can be either in straight chains, or they can be in branching alkanes like this one. Look at this one. Here we've got a straight chain of carbons, and then now we've got a branch right there. So that's why it's called branching alkanes. And of course, rings are in the shape of a circle or some sort of circle, and that's how we get that. So also there's several ways of showing how we can write out these different formulas. All of these have got the C4H10. This is right here is butane, and so let me go and show you something here. Now this right here is not specific, but notice that this has got 4 C's, and if you count them, it's also got 10 H's around it. So if you look at this specifically of this structural formula right here, this got 1 carbon and it's got 3 H's attached to that carbon. So we can also write that like this, the condensed structural formula. Here's 2 of them. Here's 1 carbon with 3 H's around it, just like up above, and again here too. It is the same thing here too, and I'll talk more about these 2 in a later moment here. Notice that this carbon has got 2 H's attached to it, so it's CH2, C, and then the 2 H's are always written after the carbon. And then how many hydrogens here? 2 again, so let me go and write that out, C, and then this is going to be a H2, because there's two hydrogens attached to that carbon. And I forgot to write that down here, and down here also. This was just smushed together more. You know, in the days that they did typewriters, we always had it written like this. And then now we've got 1 carbon with 3 H's around it, and that's pretty common to have the CH3 at the end. Okay. Now notice, and we won't be doing this one. We will do, I mean, you don't need to write them in condensed structural formula. I know some students like to, but we don't have time to really pick apart this and be real successful at this because we're running out of time. It's just fine writing them like this. Okay, notice that on these ones, these are also butane. Here's my CH3, CH2, CH2, CH3. So it's just written with the bonds because this is more the shape of what the actual thing would look like. But then also this is also, notice here, each one of these bends here is a carbon, and each one at the end is also a carbon, and they've got the appropriate number of hydrogens on them. So it's kind of a different way of looking at it, and it is something that we won't be doing, but I just wanted to at least show you. Okay, moving on. Anything that has got all single bonds, like we saw before, okay, every single one is a single bond between all the C's, it'll be called an alkane. In a nutshell, anything that's got at least one double bond will be called an alkene, and I will talk more about this too. And anything with one triple bond will be called an alkyne. So, you've got them looking like this. There's a triple bond there. There's got 3 pairs of electrons, 2 pairs of electrons here for alkenes, and alkanes have all got 1 pair of electrons for each bond. It's something that we learned quite a while ago. Okay, now looking here, there's more ways of looking at this. So if I had a carbon chain, a hydrocarbon chain that had 2 carbons in it, like right here. Okay, well, let's do 3 carbons for a prop. Okay, so we've got 3 carbons here. Okay, and then we're going to write the bonds to the H's, even though we're not going to write out every single H because that's a pain in the butt. Okay, so what we're going to do is we're going to write the bond to it. So every carbon must have 4 bonds. This right here would be, this has got 3 carbons, number of carbons. Okay, so it's going to be called a prop. Okay, they're all single bonds. They're all single bonds, so it's going to end in an ane. So that's propane. Okay, if it was something really long, you'd still count the number of C's. That'd be hex in this case. And then you'd figure out, well, gee, this one's got 1 triple bond or something, and so it'd be hexyne. Okay, I'll talk more about that here, but I just wanted to give you a preview. And this is a spot that you want to always come back and use this information for like a cheat sheet to help you out with each problem that you've got. Okay, before we get drawing and naming them, I wanted to talk about one more thing, and that's isomers. Isomers. So right here is butane. Okay, it's got 4 carbons, that's but. Okay, and so they're all single bonds. They're always alkanes. They're all single bonds. And so I would ask you, draw me another structural isomer of butane. Well, it's still got to have 4 C's, and it's still got to have 10 H's. Okay, so what we'll do is we'll take a C off of here and put it in the middle. So it'll be like this. It's no longer butane, but it is a structural isomer of butane. So I'm taking that C and I'm putting it in the middle here. And there are no more structural isomers here, but they both will have the same molecular formula for them. So those are isomers. Okay, this is a structural isomer of butane, and it'll have the same exact molecular formula. Okay, let's look at naming these. What I want to do is I want to talk about how do we name them, and then we'll have some self-quizzing time here too. Okay, so this right here's got 1, 2, 3 carbons. Okay, and let me get a marker here. So I've got 3 carbons, so that's going to mean that it's a prop again. Now this one here is kind of hard to tell because it is in the condensed structural formula. So maybe you want to write it out. There's 3 H's. It's going to be connected to another C with 2 H's on it. Okay, it's connected to another C with 3 H's on it. So if you can tell that this right here is all single bonds, so it's going to be an alkane. So this is propane. Okay, looking at this one, we've got 2 carbons. Okay, so number of carbons is 2, so this is going to be an eth. Okay, and it is all single bonds, so it's going to be an ane again because it's single bonds. Okay, and then let me get this. Let me look at a couple more here. Oopsie. Okay, looking at this one, we've got 1, 2, 3, 4. You're probably getting sick and tired of buttes here, but this butte is actually going to be a butte. But notice it's got one double bond. Okay, and so one double bond means that it has got an ene on it. So it's going to be butene. And you probably also notice that this one right here is also a butte because it's got 4 carbons. Okay, and it's also got another double bond, so it's also an ene. But these things are two different critters. They've got different melting points, different boiling points. So you've got to tell your reader which one that it is exactly. And so we always label the carbons in our head or else we write it on there. And so this is double bond is located after the first one. So this will be 1-butene. Okay, and 1, 2, 3, 4. So this is located after the second one. So it's 2-butene. By the way, there can be no 3-butene. Just looking at this, we cannot go and take this off of here and put this on there because it's really this molecule switched around. Okay, so you can't have that happen. Anyway, also, do you remember in chemistry, what don't we write in chemistry? We never write ones. So 1-butene is, you can write it on there. You don't need it though. And I won't be writing it on there either. It's always assumed that it's after the first one if you've got that situation going. Now these ones are in circles, so they've got a special name. They are cyclo, like circle. And then there's 1, 2, 3, 4, 5. So this is going to be a pent. They're all single bonds, so that's an ane. Okay, what would be the name of this one? You can pause it for a second and quiz yourself. It is 1, 2, 3, 4, 5, 6. It is a cyclo hex because it's got 6 C's, and it's all double bonds, single bonds, so they're a cyclohexene. Hexane, excuse me. Okay, moving on to the next one. Practice drawing some. Okay, so F means 2 carbons, so it's going to be like this. Okay, all single bonds, so you need to make sure that every carbon has got 4 bonds on it. That's beautiful. Okay, butene. But means 4 carbons, and this right here means it's got at least one double bond. So 1, 2, 3, 4. And now I know where this is located because there's one understood there. It's right there. Now I need to make sure that I've got 4 bonds on each one. This carbon now has got 4. This one's got 3. I'm going to add a bond to it. This one's only got 2, so I'm going to add 2 bonds to it, so it gets 4 bonds and 4 bonds there. Why don't you go ahead and look at the rest of these. I'm going to pause the video and I'm going to post the answers, so take a moment and pause it. All right, so where do students go wrong on these? They go wrong by having the inappropriate number of bonds on things. So like quite often on these ones, they will have 5 bonds around the double bonds. Do I need to have these go up and down like this? No, I was just taught in my organic chemistry class that they are bulky, that those hydrogens, that they take up space, so they probably won't be next to each other. But you got to remember that these bonds are always turning all the time. Okay, moving on to the next one. Oh, did you recognize that this is a 1 understood in front of that nonene? Okay, so quiz yourself. I'm going to go and put the answers on here in just a moment. So pause it and quiz yourself on the names of these. Okay, so this is a hexine, and I hope that you notice that you'd have to start counting over here because we need to have the lowest number on these. So this is not going to be a 1, 2, 3, 4, 5 hexine. When you go and you see that this one could be counted from this side, it'd be after the first carbon. So you'd actually start counting the carbons from the side that's got the double bond or the triple bond, and then you can continue counting that way. And the rule of it is to make it so it's got the lowest number there. That's the rule. That's how you decide which one to start counting from. Okay, this is a little bit easier because this one right here is the same either way that you count it. So it's 3 hexine. This butene right here that you've got is not going to be 3 butene. You need to start counting on this side, because the rule is that you're going to count from this side to make this number